This is an ordinary Roku TV remote control. They work fine, the batteries last a pretty long time, and AAA batteries are pretty cheap. But inevitably, when the battery finally does die, it's gonna be when you just sat down with a fresh party pizza and a cold drink to watch the newest episode of Peripheral that just came out. You might go over to the junk drawer and dig around and nope, not what you need. A guy could just stock up on AAA batteries. Sure, that's boring. I was thinking about a solution that's like 2% more dystopian cyberpunk future-esque. This is a Philips Sonicare toothbrush. This thing charges wirelessly by just dropping it into this little glass cup. So futuristic. Normally, I wouldn't think it's very sensible to rip apart a $200 toothbrush just so I can charge the batteries in my remote control wirelessly, but it just so happens that I had the mechanical parts on one of these things fail recently, and when I reached out to Philips to get it fixed, they just sent me a new one and didn't ask for the old one back. So, let's rip it apart. My plan is to dissect this thing and hope that the battery that's inside it is 3 volts or higher. This remote uses 2 AAA batteries that are 1.5 volts each, and they're situated in series. When batteries are opposite directions like this, that means you add up the voltages. So this thing uses 3 volts. My initial thought is that this thing probably has an 18650 battery in it, like everything else on Earth. That's one of these bad boys. They're like a little bit fatter than a AA battery, and it's just the right shape and size to have one of these in here. Maybe I can make my way in here and we can make ourselves a wirelessly rechargeable Roku TV remote that's never gonna let me down. Or I guess maybe I started my office on fire, which would also be worth posting. So this toothbrush doesn't have any obvious ways into it. There's no screws, there's no clips to push to open it up. In fact, I don't believe that this was meant to be user serviced. Imagine that. So I'm taking this thing over to the warehouse. I'm gonna put it in a vise, grab a Dremel tool, and get to work. After a few minutes of surgery, I made my way through its outer casing. With a bit of work, I was able to just break it apart and bend it away from the battery to get to the main board inside, still intact. Anyway, here it is. The buttons still do stuff, and most importantly, the contactless charger thing still works. So I was wrong about it being an 18650. Here's an 18650 battery, obviously a lot bigger, a lot fatter, so this thing doesn't really hold that much power. But a TV remote doesn't need that much power. These 18650s are in a ton of stuff, like older laptop batteries, usually like 3 or 4 of these just in series. Most of the like big battery backup things for your phone will just have a few of these things laying inside if you open it up. Even those 18 to 20 volt drill batteries, like Ryobi batteries or DeWalt batteries, it's just a case with a bunch of these little buddies inside. But nope, this one is smaller, definitely different. It had a sticker on it, but none of the numbers came up on a search on Google, other than the word Lith Plus, which is written right on here. Turns out this is a lithium-ion battery with a nominal voltage between 3.2 and 3.6 volts. That's perfect. Most modern circuits for tiny little electronics will have like a range for the voltage that they'll accept, because for instance, these 2 AAA batteries that come in the remote, when they're super fresh, they're 1.6 volts each, so 3.2 volts together. But by the time these batteries are dead, they might be down to like 1.2 volts and still work, which means this remote has to function accepting either 2.4 volts all the way up to 3.2 volts or so. This thing will probably work without getting damaged. We'll find out. So let's test this battery and see what it's offering. Okay, so this thing tests in at 4.06 volts. Kind of high, but it should work. That means the next order of business is finding a way to get the power out of here and into here. This board has a couple of contact points on the top. These 2 contact points send the same voltage. So I'm getting 4 volts out of those 2. While I wait for that to heat up, I'll take a chunk of an old extension cord, make me some wire. Nothing like tiny copper wires flying all over my electronics all over the room. Assume this is hot by now. I maybe have too big of a tip on the soldering iron right now, but we'll see. We have determined that the positive is on the right, I think. Okay, getting 4 volts. So far so good. Should be as simple as getting the positive end of this thing onto here and the negative end onto here. Sometimes can help to use a little bit of flux. We'll schmutz a little bit of that onto here and onto here. Okay. That's actually pretty firm on there. Let's jam that thing in there. What craft is complete without a hot glue gun? Gorilla Glue, hot glue gun. Who knew they made one of these? I need to load another stick. Ooh, well, that's not very promising. Oh, we blew it. I blew it up. Well, shoot. It looks like at some point when I was putting this thing together, I managed to cross the positive and negative wires. This board has a BMS built into it, a battery management system, which is a great safety measure to make sure that if something goes catastrophically wrong, like the positive and negative terminals getting crossed, that it doesn't start the battery on fire and have like a runaway burning thing, because this is supposed to be inside a toothbrush. So great for safety, but unfortunately this thing is toast now. It sort of falls on its own sword so that it breaks the connection and the battery won't start on fire. And I don't have another one of these, but we're too far in to just quit, so it looks like it's gonna be an 18650 after all. I actually ordered a bunch of these from AliExpress to mess around with, and also a bunch of little tiny components that charge them and keep them safe and do other different things. So what I meant to say earlier is that we're gonna have a Roku remote with triple the battery capacity, and it charges through USB-C. Not quite as cool, still pretty cool. So here's what we're looking at now. I wanna marry this battery with this remote control. I also want this battery to be able to be charged, and that's where this tiny little board comes in. This is an IP2312. It'll accept power from any USB-C source. This little guy does the job of automatically stopping the charge at 4.2 volts so this doesn't cook and explode and all that. I'm also going to add a tiny little BMS to this system, a battery management system. Normally these are designed to make sure the batteries don't get overcharged or over discharged, but since this thing already has an overcharge limiter circuit thing in it, I'm just going to be using this for the discharge side. So this will be between the battery and the remote control, making sure that the remote control doesn't drain the battery down too far and make it useless. This little guy will stop this battery from functioning below 2.45 volts so it doesn't get too low. Okay, so these batteries are a little different from normal batteries. They don't have like a peg on the positive end. You definitely have to have the positive and negative correct. The easiest way to test for that is just with a voltmeter. The way you know you have this right is when you test it, it'll say the volts. This is 3.94 volts, but if you happen to test it backwards, it'll still say 3.94 volts, but it'll have a negative sign in front of the reading. So if you have a negative sign in front of the reading, your red lead is on the wrong side of whatever circuit or battery. Is this hot? Woohoo! That's hot. So you do not want to heat up a battery. Actually, I'm going to be spot welding it onto the battery, but I'm going to start with the components that go to this BMS first. Heat these up to get rid of these. This tiny little thing, this is the power positive. Just going to get that onto the positive side. I'm not real experienced at this, so pardon me if my soldering methods are embarrassing. That's going to the remote control. Okay, so these wires are going to be for the charger. For charging, I don't need protection from the BMS. So for charging, I'm just going to connect two wires to the outside of this nickel plate. You know what? I'm going to use the little alligator grabby arms. Okay, so this is just going to... Okay. That's for my little chippy going to the battery. So now the BMS is connected down into the remote control. The battery charger is connected to the outside leads of the BMS, which is going to go to the battery itself. For that connection, I've got this little spot welder. Just got this thing on Amazon. It was like 50 bucks. So I want to spot weld to the top of this battery. This button says it's ready. I have it on full power because I don't know what I'm doing. As soon as it makes two connection points, it'll just do a weld. So I'll use the first one to hold it in place. And the second one, it's not terrifying at all. This one might be harder. What's happening? I saw some smoke. You're kidding me, I have these backwards. After I just said to check. Well, maybe fried this little board. I did see a poof of smoke. Luckily, I bought these in bulk. What I meant to do was positive end of the battery, positive side of this thing. Get some solder floating on the end of this little fella. So you don't want to heat up batteries. You don't want to heat up the end of a battery at all. And the spot welder doesn't leave heat, like it doesn't saturate heat because it's such a tiny little point that it heats up. You could solder a nickel strip to the end of a battery and it works, and people do that. But if you heat up this battery just a little too much, you'll ruin some of the piles that are in there. It'll lower the capacity of the battery, or worst case, it'll set everything on fire. Good stuff. So this is all put together. I have no idea if it works. I'm gonna use a little bit of this Kapton tape. This is electrical tape that is heat resistant. I want to just cover up first connections so they don't, I don't know, nothing drops on them and lays across. God, this thing is really ugly. To complete our cyberpunk future look, hot glue is going to be used a lot in the future. I'm super good at cord management, and then my little USB will just, where do you want to live, little buddy? I don't even know if hot glue is electrically resistant. If the circuit is receiving power, if I didn't blow up the BMS when I put that on backwards. Okay, well, good news is the BMS did its job. Bad news is I broke the BMS. Battery's receiving power, but it's not giving any out. Mistakes have been made, again, but third time's a charm. And luckily these things are, they cost nothing. These are like a few cents. So not the biggest thing other than I've wasted your time. New BMS, I'm just gonna leave the other one on there. So this whole thing should be technically hooked up now. Didn't see any poofs of smoke. Okay, yeah, so we got 4 volts going into the remote. We have to make everything live together in harmony. Glue in these cords so when I move things around, they don't move. All right, so will it charge? I have a little backup battery here. I think if I plug this in, it should light up. Yeah. Okay, that's gonna be red until this battery's charged and this will turn blue. It'll automatically cut itself off. Let's go see if it works on the TV. Yeah. Huh? Okay, there you have it. If you want a really ugly TV remote where the battery lasts way longer, I bet this battery would last for a year before you have to recharge it. And when it does, you can recharge it with USB-C. Follow these simple instructions. I have a 3D printer I'm gonna be putting together, and maybe, hopefully, maybe I can make a case that's a little more attractive just for the whole remote, because I just take all the cuts out of there. So look forward to that project in the future. This has been 18650 Batteries with Nicholas Johnson at the Space Warehouse.